this is your review for Chapter 4. The first thing I'd like to do is go through the proofs that you had on your worksheet. So if you will please check your answers as I go through them. The first one, the given information was M is the midpoint of AB. And M is the midpoint of AC. So 1 and 2 statements are our two givens. So if M is the midpoint of those two segments, let's look at AB. I'm sorry, it's the midpoint of BD. Makes a little bit more sense. So if M is the midpoint of BD, then that means DM is going to be congruent to MB. And if M is the midpoint of AC, then CM will be congruent to MA. So from that, we can write line segment DM is congruent to line segment MB. Definition of a midpoint. And then we can put, since M is the midpoint of AC, we can put AM is congruent to CM by definition of a midpoint. So now we have two congruent pieces of our triangle congruent. Because we are trying to prove triangle DMC congruent to triangle BMA, we want to locate those triangles, and we already have two congruent pieces, a side and a side. Then we can say that we have vertical angles that are congruent. I'm going to put a 1 and a 2 in the angles, so then I can say angle 1 is congruent to angle 2 by the vertical angle conjecture. So then our final statement will be triangle DMC is congruent to triangle BMA by, now let's look at our picture. Here's an angle. We know it's not going to be ASS. We've got a side, then an angle, then a side. So by side, angle, side conjecture. Okay, so that is the first proof. The second proof, the picture looks like this. We are given that line segment AD bisects line segment BE. If we are bisecting a segment, we are cutting this segment in half. So that means BE is the segment that is being bisected. So BE is being cut in half. The second given is that AB is parallel to DE. So both of these are given. Notice how I am numbering them. You want to make sure that you do that on both sides. Okay, so now we don't have any congruent parts yet, but I know that EC will be congruent to CB by definition of a segment bisector. I can look at my parallel line, so AB is parallel to DE, which means I will have alternate interior angles that are congruent. I also have vertical angles if I want to use it. So I am going to state, here, I'm going to use the vertical angles. So I am going to state that angle A is congruent to angle D by the alternate interior angle conjecture. Then I am going to state that angle ACB is congruent to angle ECD by by the vertical angle conjecture. And then I can state the triangle ABC is congruent to triangle DEC. And from looking from what I did, I have a congruent side, an angle, and an angle. So I look at my picture. I used angle A and angle D. So I have angle, angle, side conjecture. Okay, the last two are on the back. The first one, we are given that GK is perpendicular to MR. So I want to write that in my given statement. The second given, GK bisects line segment MR. That is given. So we know that perpendicular lines form 90-degree angles that will be congruent. And if GK is bisecting MR, we're bisecting the segment. So it's going to make those two segments congruent. And then we have a shared side. So my third statement is going to be that angle GKM and angle GKR are right angles. That's my definition of perpendicular lines. And then I can say that they are congruent. Angle GKM is congruent to angle GKR by all right angles are congruent. And then I want to state, so there's our first angle. I want to state that line segment MK is congruent to line segment KR by definition of segment bisector. So there's a side. And then the last piece that I need is that GK is congruent to GK by the reflexive property, or you can say shared side. Now I have three pieces. If I look at my picture, it goes side, angle, side. So then I can say that the two triangles, GKM, is congruent to triangle GKR by the side, angle, side conjecture. And then the last one, proof 4. We are given that angle F is congruent to angle M, so I'm going to mark those congruent. I'm given angle 1 is congruent to angle 2, so I'm going to mark those congruent. And then we have a shared side. So this is probably the easiest proof on the sheet. We have our two givens. And then we have our shared segment. So given, shared segment, or shared side, or the reflexive property. So then I can say that there's my three parts already. So I can say triangle FPL is congruent to triangle MLP by the angle side conjecture. That's not what I'm trying to prove. So then I need to say FP is congruent to ML by CPCTC. And that is the proof worksheet. The next thing I'd like to talk about is your foldable that I'd like you to make for a review sheet. So if you will get that out, you can put me on pause if you need to. On the front of the first flap, I'd like for you to put triangle sum conjecture. That just goes on the flap. So on the inside, you want to write the three angles of a triangle sum to 180 degrees. I think it would be a good idea to put an example in here. So if I have one angle that's 30 degrees and one angle that's 40 degrees, then the other angle is going to have to be 110 degrees. So all three of them have to add up to 180. If you're given two, you can always find the third one. The second slide, on the front, label it isosceles triangle conjecture. On the inside, I'd like for you to draw a picture of an isosceles triangle. We have congruent sides, so we know it's isosceles. So this is the vertex angle that forms the two congruent sides. If we have an isosceles triangle, then we automatically have the base angles congruent. So in an isosceles triangle, the base angles are congruent. The converse of that statement is also true. So this is a base angle, and then you want to make a note that the converse is also true. So if the base angles of a triangle are congruent, then it is isosceles. Make sure you look in your notes, in your notebook, because you have all these conjectures written out there. The next slide. On the outside, put triangle inequality conjecture. So the triangle inequality conjecture, if you will remember, the longest side is across from the largest angle. So let's say that this is 130 degrees. This angle is 20 degrees. So we can solve for the missing angle. If that's 150, then this one has to be 30, so they sum up to 180. The longest side is across from the largest angle. So side A will be the longest, side B will be medium length, and the side across from the 20, side C, will be the shortest. So the longest side is across from the largest angle. And the vice versa, that is also true. So the largest angle is across from the longest side. Okay, triangle inequality conjecture. Your next slide, or your flap, exterior angle conjecture. This is one that you all had trouble with on the quiz, so make sure you understand it. If you extend any side of a triangle, it is called an exterior angle. It will equal the sum of the two remote interior angles. I'll label them 1 and 2. I'll label the exterior angle 3. So the measure of angle 3 is equal to the measure of angle 1 plus the measure of angle 2. So the measure of an exterior angle is equal to the sum of the two remote interior angles. So an example problem there. If I'm given an exterior angle, let's say the measure of it is 3x, and all I have on the inside is, let's make this 40 degrees, and let's say this one is 90. So 3x equals 40 plus 90. So then I can solve for x. So 3x equals 130. X is going to equal 130 over 3, which does not divide evenly. So you can write it as 43 and a third is what x will equal. Okay? So a lot of those you're going to have to write equations and solve. Your fifth flat, the triangle congruence conjecture. How do you prove triangles congruent? We learned that you can do it by side, 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 angle, side, angle, or side, angle, angle, which can also be written as angle, angle, side. So those are your 4 congruent conjectures. 4 ways to prove triangles congruent. Those are the only 4 that work. Your next slide, slide number 6, or flat, CPCTC. Make sure you know what this stands for. Corresponding parts of congruent triangles are congruent. CPCTC. You have to have congruent triangles before you have corresponding parts. So if I tell you that triangle ABC is congruent to triangle DEF, the 6 corresponding parts are angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F, and then your line segments. Line segment AB is congruent to line segment DE, line segment BC is congruent to line segment EF, and line segment AC is congruent to line segment DF. CPCTC. 2 more flats. This next one, vertex angle bisector conjecture. So on the inside, we want to make an isosceles triangle. I'm going to make AB congruent to AC. We already know that angle C is congruent to angle B. But if the vertex angle is being bisected, then that means this line segment AX is also a perpendicular bisector, making CX congruent to XB. So if triangle ABC is isosceles and line segment AX is an angle bisector, then AX is also a median and an altitude. So lots of congruent pieces there. The two triangles, triangle AXC will be congruent to triangle AXB. So all of the pieces are congruent. And then your last slide, the equilateral triangle conjecture. That's what we want on the outside, on the inside. If it's equiangular, it's equilateral. If it's equilateral, it's equiangular. So, every equilateral triangle is equiangular. And you might as well put 60 degrees there because it will be 60 degrees. And every equiangular triangle is also equilateral. Study hard for your test.